In the Blue Ridge Seax DVD, the bladesmith Jesus Hernandez will embark you in a journey where both old and new methods will be utilized to make a Viking short sword. Even though this DVD is 2 hours long, not all the techniques could be covered in detail, but if there is enough interest from the viewers, processes like smelting or making fittings could be made into full-length DVDs in the future. Smelting is the process of turning raw iron ore into metal. Iron oxide is converted into metallic iron with variable carbon content in a process called reduction, which takes place in a clay furnace. Jesus always sees King Arthur pulling the sword from the rock as an analogy to smelting. Layer upon layer of iron ore and charcoal are fed to the hungry furnace for hours. Slag is the term used to describe the non-metallic component of the ore. A flow of slag heralds a successful smelt and hints to what is left behind in the furnace called bloom. The bloom is a metallic mass pulled from the rock.
There it is.
This smelt was hosted by Mark Green. Having one or more friends help during a smelt makes things easier in an otherwise exhausting task for one single individual to carry through. In this process, the bloom will be transformed into a workable bar of metal. Notice the weight of this piece of bloom. It's almost 1.7 kilograms. Jesus will continue to document the weight during the video to show you how significant the loss of mass is before reaching the final shape of a sword. The spark test is an inexpensive way of estimating the carbon content of a bloom. In this case, the length, color, and branching of the sparks suggest a medium carbon steel bloom. The forge is fired and the bloom is placed inside and allowed to reach welding temperature. Patience is important, as such a large mass will take time to get hot enough. As the metal gains temperature, its color changes, reaching a bright yellow when it is ready to be forged. Just before that happens, the slag becomes molten and takes the appearance of liquid butter. It bubbles and drips from the surface of the metal. Jesus, I don't think that one is going to fit that way. Don't be stubborn, man. It's time to pick up a hand hammer and shape it the old-fashioned way. Now it will fit. But it will first need to be put back into the forge to get it hot again. And now it can be given a good squeeze in the press. It's Jesus' preference to use a hydraulic press for consolidating blooms. The slow but powerful force of the press seems to be superior to the other methods or tools. Blooms are like Swiss cheese. They're full of voids that need to be closed up in order to make a solid bar of metal. There are different strategies to close up those holes and prevent air pockets that will later blister up when you least expect it. The Japanese method of flattening the bloom into plates of about a 1/4 inch thickness, which are later on stacked and welded together, is about the most effective, but also the most time-consuming way of doing this. But this is not a Japanese blade, so we will follow a different strategy and simply try to compress the metal and fold it as many times as needed. It is fascinating to watch the press make easy task of something otherwise quite laborious. Slag and scale are separated from the metal by switching the direction of compression and later brushing or scraping it off. The bar is further reduced in size to about ½ inch thick by 2 inches wide. The reason for these measures is no other than to comfortably fit the size of the jaws on this press. When the bar has reached the desired measurements, it's time to cut it in half. Jesus prefers not to cut all the way through and leaves enough material to work like a hinge and facilitate folding the bar later. This is the first weld for this bar. Jesus does not feel that there is a specific number of folds or welds that one has to put in a bar. The bar will speak for itself and let you know how many folds it needs in order to behave as a solid piece of metal. The metal will move as a single mass with no structural defects or cracks when no more folds are necessary. This particular bar of steel forged very nicely under the stress of the press, reducing in size without evidence of cracking or delaminations, even when the total thickness was being reduced in half during a single pass. Notice the sparking. Who said that a propane forge can't get hot enough to burn metal? This is the second fold, or welding pass. If you were paying attention, you would have noticed that the overall mass of the metal has already reduced in size considerably. Mass is lost to the removal of slag early on, and later to scaling, the term used to describe oxidation or burning of the surface of the metal. At this point, it looks like this bar feels quite solid, so Jesus will use the next passes under the press to give it its final dimensions for now and break for the day. At the end of the bloom to bar consolidation round, the mass has been reduced to 80%. The process of creating a torsion bar is rather interesting. First, you need to select a piece of consolidated bar that has the right character. By that, Jesus means that there has to be some degree of contrast between the layers of the bar. Using modern steel in the process known as pattern welding, this is achieved by alternating layers of contrasting steels, such as 1095 and 15N20, or L6 and O1. Jesus' previous experience using homemade steel has taught him that this somewhat artificial process of alternating layers is not necessary. Most bars of homemade steel already have a layering effect of their own, due to forging and folding of the bloom. Keeping the number of folds in the original bloom to a low number will create enough contrast for a twist bar. On the contrary, folding the bar many times over itself will result in loss of definition of that contrast. So we select a bar that has 8 layers as a result of having been folded 2 times. A little bit of ferric chloride helps visualize the pattern. This bar weighs about 1 kilogram. Jesus will start by drawing it out using the press. Making sure to keep the bar as clean as possible by scraping the scale off. Fortunately, this bar is also behaving quite nicely under the press, allowing for heavy reductions in thickness without delaminating. The bar is squared on the press to about 3/4 of an inch, and then it's time to move to a more effective drawing method, a power hammer. There's always a tool that is more efficient for a task, and the power hammer is the tool for drawing metal out. The goal for this bar is to be reduced to a long and skinny square bar of about 3/8 of an inch. It will then be cut in half to make 2 separate torsion bars. The weight loss during the drawing out phase is about 20%. Keep in mind that we had already lost an initial 20% to make the bar. The plan is to heat up both bars at the same time and twist one while the other one remains in the forge. The bars will be twisted at welding temperature. The hardest part is keeping track of which bar is being twisted clockwise and which one is being twisted counterclockwise, as well as how many times you twist each bar to keep things even. So I'll try to keep quiet and let Jesus concentrate on his task. Jesus uses a modified pipe wrench to grip the bar for twisting. This bar goes clockwise. This one counterclockwise. How many times a bar is twisted depends on the comfort level of the smith. There's always a limit to the performance of the material, and twisting too much or when the metal is too cold can result in shearing of the bar, which will then have to be scrapped and a new bar made. That is easier said than done, as we are talking about having to go back to square one and make a new smelter to make a new bloom to consolidate into a bar to be drawn out and to be twisted again. That type of setback in actuality represents weeks of work. As a final step, the bars are cleaned from scale and straightened on the anvil. An additional 20% of the mass has been lost during the twisting. This is clear and irrefutable proof that doing the twist burns calories. Making the bar for the laminated edge is a straightforward process, no pun intended. The bar selection is simple. Jesus does not need to worry about the pattern here, as the transformation imparted on the material by the repeated folding will result in a similar appearance in the end. The process is basic. Take the bar from the forge, cut it partly in half to create a hinge, scrape off the scale, flux it, and fold it. Weld the two halves, draw it out, square it off, fold it again, weld it again, draw it out again and again and again, but I'll spare you from having to see all of that. One thing, don't forget to clean it up. After the last fold, Jesus will square the bar again with the intention of turning the bar 90 degrees for the final drawing out and to cause the pattern of layers to show on what will become the sides of the blade. A system of stops that Jesus designed for his press allows him to give exact dimensions to the final bar. The bar is now long enough that it can only be properly heated and shaped by half its length at a time. Final shaping will be done on the power hammer. The pattern of layers is visible to the naked eye. This bar used to be 1.4 kilograms and now is about 1 kilogram. That's a 30% loss to become the edge bar after having lost 20% in going from bloom to bar. So now it's time to put the billet together from the different bars. The final billet will have 4 bars: the straight laminated bar, will be divided in two lengthwise. One section will be 3/8 of an inch wide and will become the spine. The wider section will become the edge of the blade. The twist bars will be placed between those two. The first welding pass will be done under the hydraulic press. This operation is quite critical. If it were to fail, all the work put into the blade at this point would be lost. Jesus has to ensure that all the bars are aligned correctly and don't slip sideways during the weld. To ensure that the welds are sound, the billet is taken to a welding heat and another welding pass is done using a hand hammer. This is done one section at a time. Then the power hammer is used to draw the bar to the desired length. These operations are always done at welding temperature. Finally, the billet is cleaned up from scale and straightened out on the anvil. The combined weight of the blooms used to make this billet was 3 kilograms, and now we are down to 1/3 of that. The billet needs to be further prepared for forging into a blade by cutting off the rough ends and removing a wedge of metal from the tip of the blade. The tip will be shaped by forging it backwards, causing the twist bars to gently turn upwards, following the curve of the edge. 20% of material has been removed during this operation. Jesus is now ready to forge the blade. This operation will be entirely done by hand. Jesus feels that there is no better way to shape the blade to its final form. The metal will move under the hammer with more or less resistance, giving continuous feedback to the smith as to how hard and how to deliver the hammer blows. Jesus forges the bevels first, starting from the tip of the blade. As he does so, the edge takes on its curved appearance. For most of the work, he uses a 4.5-pound sawmaker's hammer with a short handle. To form the tip, he uses a 2-pound hammer with a more rounded face. Jesus continues to forge the edge bevel along the length of the blade. finally reaching the other end of the blade, where he will forge what will become the tang. The last forging step is to straighten the blade. "30% of the mass was lost during the forging of the blade." Before any grinding is done on the forged blade, the heat treating process begins. The first stage is to normalize the metal. This is a process consisting of bringing the blade to the so-called critical temperature, which corresponds to a fully austenite structure. A couple of cycles will be sufficient for a simple carbon steel like this. The heat treating oven is brought up to a temperature of around 1500 degrees Fahrenheit. The blade is placed inside and watched as it changes to a dull cherry red color and finally brightens up as its internal structure changes into austenite. Let's run that again a bit faster, using the magic of video editing. The transformation becomes more noticeable that way. Even Darth Vader would be proud. After normalizing the blade, it is taken to the grinder to clean up the forging scale and to give it its final profile. A 36 grit belt is used first, and it is finished with a 120 grit. The tip will be shaped to a spear point. Although claying a blade to control how far the edge hardens is a Japanese method, Jesus chose to utilize it here based on historical evidence of edge hardening in some seaxes. It is quite likely that this type of steel would have developed a natural hardening of the edge during quenching. Simple carbon steels like this one made in a traditional smelter are shallow hardening. By claying the blade, Jesus simply wanted to ensure that there would be no surprises. While the clay dries up fully, the heat treating oven, the tempering oven, and the oil for the quench are brought to operating temperatures. The blade is placed in the oven and allowed to reach critical temperature. Then it is submersed into the quench tank. The tempering oven has been kept at temperature all the while to avoid any time lapse between hardening and tempering. During tempering, the blade is heated up again to a temperature that will remove some brittleness from the edge, while leaving it hard enough to be functional. It's a compromise between edge retention and durability. Two cycles of tempering, lasting an hour each, will suffice for this blade. The best opportunity to safely straighten any warps in the blade caused by the hardening is after the tempering cycles while the blade is sufficiently hot. Fortunately, this lucky blade did not need a whole lot of straightening. The first step before moving forward in making the seax is to establish a foundation polish. Jesus will start by filing the notches where the tang meets the blade. The next step is to define the tang profile, followed by the tip profile using sandpaper backed by a metal bar that can be comfortably held with both hands. A spotlight is used to make sure that all the scratches left by the files of the grinder are removed before moving up to a higher grit of sandpaper. Then Jesus will move to the sides of the blade using the same process. Sanding can be tedious, but when approached in the correct state of mind, it becomes quite relaxing and can be a great way to exercise your level of concentration. After reaching a 220 grit polish using sandpaper, Jesus cleans the blade with acetone and etches the blade with hot lemon juice. After a few minutes, a hint of the final pattern of the blade can be seen. Everything seems to be in order to move on to the next step. With the blade in its final shape, it's time to make a handle for it. A block of padauk wood is chosen because of its toughness and stability. Padauk comes from Africa, and it's not the easiest wood to carve. After splitting it in half with the bandsaw, the profile of the tang is marked in one half of the wood and mirrored to the other half. With a sharp knife, the profile is incised in the wood. Using chisels with a flat bottom and curved neck, specially modified for this task, the wood is hollowed out to allow the handle to fit tightly. Quite a bit of going back and forth between the chisels and testing for the fit of the tang is necessary before moving to the other half of the wood. When everything fits right, it's time to glue the two halves together. You might have noticed that Jesus did not sand the mating surfaces flat. If the cut was done just right with the bandsaw, the marks left by the bandsaw blade will match along the cut and fit seamlessly together. The more clamps, the better. The tang of the blade is sprayed with WD-40 before placing it in the wood for the final fit. This way, it will be easier to remove later while performing the next task. Using a two-part putty made for auto repairs, Jesus fills in any gaps that may cause a less than perfect fit of the tang to the handle. This product hardens in less than 2 minutes, so there's no time to fool around. Next, Jesus makes two cutouts in paper with an inverted teardrop shape that will define the profile of the handle. One is just slightly smaller than the other to create a pleasing taper from neck to pommel in the handle. Jesus will use the belt sander with a 36 grit belt to profile the handle, making sure that the resting surface is perpendicular to the belt. First, the woodblock is squared off on all 6 sides. Then the teardrop cutouts are inscribed on the handle ends. And connected with straight lines. Bulk material is removed with the bandsaw. And the rest is done on the belt grinder. A fresh belt is a must during this stage to avoid burning the wood. Jesus removes material first from the corners and slowly continues to remove material from both ends to approach the previously inscribed teardrop profile. Finally, the profiles of both ends are connected by removing the wood from the center of the handle. This could be a perfectly functional blade at this time. Using 120 grit sandpaper, the marks left on the wood by the grinder are removed. The next step is to inscribe a mark where the pommel and the ferrule will be. Jesus will then cut into that mark and chip away the wood that does not belong there. First by cutting towards the incised mark and then away from it. Working slowly and taking small shavings at a time is the best way to do it. This activity can be quite relaxing after all the loud forging and grinding of the previous weeks. With the handle's primary shape finished, it's time to make the ferrule and the pommel. Jesus prefers to call them the fuchi and kashira, using the Japanese terminology. It amazes him to see the similarities in construction between the seax and the Japanese blades. Two completely different cultures miles away from each other and no known contact between them. Jesus chooses copper to make the fittings. Some rough measurements are used to determine how much copper plate will be needed. The starting thickness of the copper plate is 1/8 of an inch, but using the rolling mill, the thickness can be modified at will to fit the task at hand. Here Jesus is annealing the copper to make it more malleable. Then he pickles the copper to clean the surface oxidation. After a few seconds in a bath of baking soda to neutralize the acid, they are ready for the next step. Which is to fit them to the recesses carved in the handle. Being softer now, the copper can be worked by hand. Or with a small hammer. Excess metal is cut off with a jeweler's saw. Now the copper can be further hammered to the final shape in preparation for soldering. To be precise, what Jesus is going to do is brazing, using a hard silver solder that flows at temperatures over 1,000 degrees Fahrenheit to make a stronger joint. The copper band is bound with wire to keep its shape and to make sure that the joint surfaces are in close contact with each other. The wire becomes a convenient way to hold the workpiece for the brazing operation. The key to this process is clean joint surfaces and using just the right amount of heat in the shortest amount of time feasible. Looks like the fit is tight. Some filing will fix that. It's always better to be tight and have to file down some than to have a loose fit, although the real art is to be able to adjust both circumstances, either too tight or too loose, to a perfect fit. Next, Jesus will make a cap to complete this fitting. The profile for the cap is inscribed on the copper plate using the band as a template. Excess material from the band is removed with the saw. Then the copper plate is cut, following the inscribed profile. The resting support on the belt grinder is adjusted to be 1 degree off from being perpendicular. This creates a taper in the plate that will allow it to be pressure fitted to the band. Flux is applied. A wire is wrapped around the band again, as Jesus uses the same type of brazing material for this joint as he did for the joint in the band. Being that both will flow at the same time, he wants to keep it together in one piece. After brazing, it goes in the pickle and neutralizing solutions. This is the rough ferrule. To be functional, it will need an opening for the tang to slip through. Jesus will put a hole with a drill press and use the saw to cut out the opening. Here Jesus is test fitting the ferrule to the blade and the handle. And he will use the same process to make the pommel. Final fitting of the ferrule to the tang is done using needle files and a lot of patience. You want the blade to fit tight and avoid unattractive gaps. But if gaps do occur, the real art of the bladesmith, as we said earlier, is to be able to fix those in an appealing manner. Here Jesus is using a small hammer to tap on a round nose punch, which will serve two purposes: to close up any gaps in the fit, and to add a decorative pattern to the front of the ferrule. Any material from the ferrule and pommel that protruded from the wooden handle profile is removed first at the grinder. Then by hand with 220 grit sandpaper. Finally, the edges of the fittings are rounded off to avoid sharp corners and complete the shaping of the fittings before any carving, decoration, or finishing touches are applied to them. It's time to carve the handle. Jesus will first spend some time in coming up with a design for the carving. Historical materials from the appropriate time or culture could be used as inspiration, or simply nature or what surrounds you could be your guide. Ultimately, this is a very personal process, and you should make it your own. Jesus draws the design on onion skin paper, which can then be either transferred or attached to the wooden handle. In this case, the design is attached to the handle and cut through to mark the wood underneath. This is a very enjoyable process for Jesus, and rather than talk all over it, I will just let you enjoy watching him. Once the design is marked, it's time to commence the carving. First, by cutting the marked lines to establish the profile of the drawings. Again, I will let Jesus show you in images what is hard to describe with words. With the profile roughly finished, it's time to use a smaller chisel to work in the details. A magnifying visor has become a need in this last year for Jesus. Age catches up to all of us. Jesus carves sitting on a chair, supporting the workpiece between his hands and legs. The control is very good, but the posture is uncomfortable after hours of carving. A bone insert is part of the design. It is fitted by hand through trial and error and finally glued in place, the excess cut off and the surface scraped to form a dome. More detailing work and then material will be removed away from the background to make the design stand out. Here Jesus is sharing another tip for fixing carving troubles. This wood chipped easily, and to fill in tiny imperfections, Jesus will make a paste from the dust created by sanding a piece of the same wood and mixing it with wood glue, then applying this paste to any voids or areas that need a little touch-up. A rim will be carved in the area that fits up to the ferrule, so that the last part of the background can be carved and scraped off. With the basic handle structure completed, it's time to embellish it a bit. Jesus will start by taking an impression of the ferrule on onion skin paper, which will in turn be used to draw a design on. The design will be symmetric on both sides, in accordance with similar fittings seen in historical examples. The design is then transferred to the ferrule using a needlepoint punch. There are different approaches to carving the design on the copper ferrule. A simple one is to use a handheld chisel with a push handle to incise the metal. A better approach is to attach the ferrule to a resin known as pitch. Pitch is very sticky. It can be softened by heat, and it becomes solid quickly as it cools, providing a very good support for working on the ferrule. While Jesus is waiting for the pitch to solidify, he works on the pommel using the handheld chisel. When the pitch is solid, Jesus uses a chisel driven by a small hammer, which is capable of more effectively chipping away the copper. The cutting profile of this chisel has a face set at 60 degrees to the workpiece. After the incising chisel has cut out the profile, a different chisel is used to define the edges of the cutout. This chisel has a rounded belly and a flat face, also set at 60 degrees. Finally, a round punch is used to create a texture within the cutout. Jesus is now holding the final result. common finding in some saxes is the presence of a ring that attaches to the end of the pommel. Copper wire will be rolled up and shaped into a ring with a protruding leg that will later be pinned through the pommel cap. The joint is brazed to strengthen the ring. Then it's work hardened to its final shape. It's also common in historical saxes to see the pommel being attached to the wood handle by means of nails. Jesus will forge 2 nails from copper wire for this purpose. A scrap piece of metal is transformed into a makeshift nail header. Making tools to make other tools or additional pieces is part of being a bladesmith. Jesus is getting ready to fit the ring to the pommel. First, he will file an opening and go back and forth a number of times to get the fit just right. He then saws a slot in the leg of the ring for peening. While everything is clean and before peening, he applies a little bit of flux as he plans to solder the joint later for extra safety. Using chisels with a progressively wider tip in the shape of a V, he opens up the slot in the leg of the ring. Finally, using a punch with a textured flat face, he peens the ring to the pommel. The textured face facilitates the grip to the metal, keeping it from slipping while it is being hammered. Next, he uses a low-temperature solder to complete the joint, and finishes making the copper nails to be used later when the handle is finally assembled. For an extra precaution, this blade's tang will be further secured to the handle with a cross pin. The sheath for the sax will be made of tooled leather. Jesus finds it easier to first create a template using a manila folder. The folder is convenient as it already has a fold that facilitates wrapping it around the blade. Any other piece of thick paper would also work. The profile of the blade is traced, and the folder extended as needed to cover the full length of the blade. Only one side has to be profiled, as the other one is symmetric and will be formed by folding in half and cutting the excess material. The template is transferred to an 8-ounce weight tanned rawhide. The best method for tooling the leather is to increase its pliability by lightly wetting both sides, then sealing it in plastic wrap and putting it in the refrigerator for a few hours, or even better, overnight. When he is ready to work the leather, he will take it out of the refrigerator, unwrap it, and work on it for as long as necessary. If he needs to take a break, he wraps it again in the plastic and puts it back in the refrigerator until he's ready to work on it again. As he did for the handle carving, Jesus has come up with a design that he will transfer to the leather. Actually, two designs. One will be for the rounded part of the leather that covers the grip, and the other goes on the flat part that covers the blade itself. A pointy tool is used to gently transfer the pattern to the leather. The leather is very pliable now, so very little pressure can easily leave a permanent impression. After transferring both designs onto the leather, Jesus uses a swivel knife to cut about 1/3 into the leather as the first stage of tooling. The swivel knife is the ideal tool for this process. It is meant not to cut too deep, and to easily rotate in the hand to follow intricate designs as it cuts. When the design is completed, it's time to put the leather away and take a break before the next step. Now it's time for using a beveler stamp pushed into the leather with a rawhide mallet. In order to create a seamless bevel, the tool is moved continuously, a little at a time, while being hammered on. This punch is used to create a shading effect. To add a little character to the design, Jesus uses a wood-burning tool to darken selected areas of the design. The next step is to mold the leather sheath to the shape of the blade. Jesus does this while the leather remains pliable. The more clamps the better, but be careful not to mark the leather by keeping scrap pieces of leather between the clamps and the sheath. It's time to glue the sheath using hide glue and more clamps. After gluing, the edge is cleaned up with the belt sander and touched up with a V-gouge. The process of stitching the leather sheath starts by using an adjustable groover to cut a channel that will then be marked with an overstitch wheel. This tool marks spots at regular intervals, which will then be punched through with an awl to create a hole. Using wax seaoo, 2 dull-pointed needles, and a technique known as a saddler stitch, Jesus arms himself with lots of patience and prepares to stitch the entire length of the sheath, coming back over stitches at least once at both ends. The final knot is pulled from the other side to become buried in the leather. Then it's time to embellish the leather. Jesus rubs in an excess of antique leather stain to give it color. Then he wipes off the leftover stain. Carnauba cream is the last touch to give the leather some protection and a bit of shine. With the leather sheath finished, it's time to move on to making the metal fittings for it. Leftover manila folder is used to transfer the profile of the leather shape and create a template of the metal fitting that extends the handle of the blade. The width of the template is transferred to copper plate. Which is then cut in the bandsaw. Annealed, and rolled to the desired thickness. The thin plate is now being hammered on the anvil to straighten it, and it will be annealed one more time. The template is now transferred to the metal, and cut using a sharp chisel and hammer. Being so thin, there's no need to use a saw. Jesus uses pliers now to shape one half of the fitting into a box-like shape. An improvised stake anvil is made from a flat bar of scrap metal and will be used to clean up the corners of the box shape. Jesus now checks the fit on the leather sheath. and make some decorative cutouts on the other half, which corresponds to the lid of the so-called box. The box and the lid are now cleaned by pickling and sanding, and they are brazed together. After cleaning up, Jesus checks for fit against the leather sheath one more time. Time to move to the chap for the sheath, a French word to denote a cap placed at the tip of the scabbard. Jesus will use the same method of construction as for the other piece. First, he will create a template using what little is left from the manila folder. Then he will transfer the template to the thin copper plate. And cut out the profile. Relief notches are needed to form a box here because of the curved profile. The box and lid are then brazed together and checked for fit on the sheath. There is historical evidence for the base metal of these fittings to have been tinned in the past. So Jesus prepares to do so by first applying some flux to the metal surface, heating it carefully, not going over the temperature used for brazing, and applying a tinning solder, which is then spread with a brush or wooden rod. This is how the two pieces look after tinning. Further decorative lines will be cut out using a compressed air engraving tool. Additionally, 3 copper rings are prepared from copper wire to become part of the metal fittings for the sheath. The copper wire can be formed into a ring by hand or by using pliers after annealing. The reins of a pair of tongs had the correct diameter for the forming operation. Each of the rings is separated from the coil with the saw, leaving a little bit of extra material overlapping. The overlap will be hammered flat and drilled through, and a pin inserted to create a permanent joint. Two additional fittings are made to hold the copper rings to the leather sheath. After forming these, they are tinned as well. Through trial and error, Jesus determines that a commercial solution used to brown iron is also capable of darkening the tin surfaces of the fittings, thus creating an antiqued and more appealing look. A long copper plate is being tinned in preparation for making a number of additional fittings for the edge of the scabbard. A homemade die and punch set is fashioned to create decorative channels in the tin copper plate. Jesus turns the edges over with pliers. And folds them into a U shape with an interchangeable homemade punch and die set. One of the rings will attach to the sheath in a slightly different way. Jesus prepares a number of copper nails in his El Cheapo model lathe, a drill spinning in the opposite direction to the belt sander. The nails are then punched through the fittings to permanently attach them to the leather sheath. All the copper fittings are darkened with a chemical solution to keep with the antique look of the rest of the fittings. Finally, a coat of Renaissance wax goes over all the metal fittings for protection. We are getting close to the final stages, and it's time to finish the wood for the handle. First, Jesus will use a stain called billetooo to darken the wood. Then, using fine steel wool, he will distress the look and remove some of the stain from high points, creating the illusion that the handle has been gripped many times. Finally, several coats of Danish oil will be applied until the wood is saturated. Earlier, Jesus showed you how to patinate the tinned fittings. For the copper fittings, Jesus will use the same billetooo, as it has the property of getting in nooks and crannies and solidifying in the spot, darkening the background of the carvings. The blade was at 220 grit polish, while we worked on all the furniture for it. It's time to move up the grit ladder and finish polishing the blade. Jesus will begin the polishing routine, starting at 320 grit sandpaper, backed with a hard metal bar that serves the purpose of being a two-handed grip sanding stick. Jesus will polish the blade at alternating 90-degree angles to make sure that the marks left by the previous grit are fully visible. His goal is to completely remove the previous marks before moving up to the next grit. As the grit becomes finer, he switches the sanding bar around and attaches the sanding paper to a strip of thick leather glued to the bar. This softer backing helps bring some relief to the blade surface, as it preferentially removes material from the softer layers of metal. As the blade will be etched in acid, Jesus will stop at 1000 grit. The blade is ready to reveal its character. This is the most exciting moment. A solution of diluted ferric chloride is contained in a vessel that will withstand heating, using a hot plate that also contains a stirring magnet. After some minutes in the solution, the pattern of the metal becomes visible. The oxides are washed away with hot water, and the acid is neutralized with a baking soda solution. All the different parts can now be put together. Traditionally, it is likely that the handles were glued using pitch. Jesus uses a 2-part epoxy, as the setting time for the pitch is too short to assemble this many parts. First, the ferrule is attached. Then the blade is set in the handle and locked into place using the cross pin. The pommel is attached next. And finally, the 2 nails that secure the pommel are hammered into place. The Blue Ridge seax is ready for its presentation.